starting for. Okay, lesson 34, reducing rational expressions. Students will reduce rational expressions with monomial and polynomial denominators. That's the objective for today. We'll get there today. So, why should we know this? Well, when you have a problem like this, you're going to be looking at problems like this later this year, and then you're going to be looking at bigger problems. This looks kind of scary, right? Yeah. And when you divide fractions, it's kind of like you have to do all this extra work, and then you're going to have to factor. Well, we could reduce and simplify things. When we factor them out, what we're going to learn today is just one side of it. You could easily just start crossing things out. And you'll be able to have these i's, math i's, and you'll be able to figure out, oh, okay, the answer we could simplify is 3 times x plus 2 over x plus 1. Now, I did that really quickly, right? So you'll be able to do problems more quickly, right? You want to save time. So that's really what we're learning today, and we'll learn that together, okay? So, two things to recall. Undefined, this is something you should know already. Undefined is when anything is divided by 0. So if you have, I'll do this on here, 1 divided by 0, it's undefined. Or if it's expression 3x plus 2 divided by 0, this is undefined. In math, we don't like undefined, okay? So we want to try to keep away from fractions that are undefined. So anything divided by 0 is undefined, okay? Turn to your neighbor, tell them what undefined means really quick.
Divided by 0.
Okay, good. And then factoring is when we break things apart. It's the opposite of multiplying, breaking it apart, okay? So there's a couple things. Those are the steps. So if you're watching the video, you could pause it. Look at the steps. The big idea, okay, to reduce is we break it down and we simplify it, okay? So that's the big idea. We break it down and simplify it. What's the big idea? Okay, good. All right, so I'll do number 1 and 2. Pencils down. You're just watching right now. Pencils down. Pencils down. Okay? So number 1, step 1. When I do this kind of problem, is step 1, I take the denominator first and set it equal to 0. I want to make sure that I figure out what would make my denominator undefined. I want to make sure I figure that out first so that it's not equal to that. I want to make sure that's an excluded value. So I took 6a squared, the denominator, and I set it equal to 0. And then I solve for a. So I'm going to divide both sides by 6. A squared is equal to 0. Take the square root. Square root of 0 is just 0. What this is saying is that if a is equal to 0, then my denominator would be 0. Because a squared, 0 squared is 0. 0 times 6 is 0. We don't want a 0 in our denominator. Why not? Because it'll be undefined, right? So what we do is we know that we don't want a to be equal to 0, so we put a little line through the equal sign. We don't want a to equal to 0. That's step 1. Step 2, we're going to factor the numerator and denominator if needed. So the numerator, we know the numerator could be just 9 times a. Denominator is like saying 6 times a times a. Step 3, we simplify. We know that 3 goes into 9 and 6, goes into 9 3 times, goes into 6 twice. A can cancel out of the top and the denominator as well. So all we're left with in my numerator is 3. The denominator is 2 times a, which is 2a. This is our final form. Then we include our excluded value, so we put a little semicolon there. And we say, oh, a cannot equal to 0. If it's equal to 0, it'll be undefined. We don't want that. That's your final answer for number 1. Okay? Again, watching number 1. Okay? Step 1, set the denominator equal to 0 to find any excluded values. So I took the denominator, set it equal to 0. I solved and I figured out a cannot equal to 0, because if it's equal to 0, it'll be undefined. Step 2, if needed, factor the numerator and denominator. I factored it, so I knew it was 9 times a and 6 times a for the denominator. Then step 3, I simplify. So I simplified 9 and 6. We know 3 goes into each of those. Simplified, cancel out the a and the a. And then step 4, I write the expression in final form with my excluded terms. So this is my final expression. Put a semicolon, really important, and then you put the excluded term, which is a cannot equal to 0. Box your answer. Okay? That's number 1. Number 2. Watch me do number 2, and then you can write pencils down. Pencils down. Thank you. Okay. Number 2. Step 1, I'm taking the denominator. R squared plus 5r plus 4. And making it equal to 0. Then I'm solving for r because I want to know what is r equal to, and so we know not to include it as a solution. We could factor this. So it's r plus 4 and r plus 1 equal to 0. Zero product property we've been using. R plus 4 equals 0. And r plus 1 equals 0. Simplify, subtract 4 on both sides on this first one. Get r is equal to negative 4. We know this is an excluded term, so we want to put a little cross out through the, or a little line through the equal sign. And then subtract 1 from both sides here. We get r cannot equal to negative 1. If that was the case, this would make our denominator 0, making our expression undefined. We don't want that. Okay, that's step 1. Step 2, factor if needed. So I'm going to factor my numerator. So r squared minus 2r minus 3 could be factored as follows. We could go r minus 3 times r plus 1. The denominator we already factored here. R squared plus 5r plus 4, we factored, it's going to be r plus 4 times r plus 1. Okay. Step 3, simplify. I look at my numerator and denominator. Look, I have an r plus 1 here, r plus 1 here. Okay, I'm going to cancel these two out. R minus 3 and r plus 4, these are binomials. You can't cancel these out separately, so this is what's left. My numerator is going to have r minus 3 over r plus 4. Step 4, write the expression in final form. You already wrote it. Write a semicolon. Then we take the excluded values. R cannot equal negative 1 and 4. Then you just box your final answer, and that's it. Okay? Any questions? All right, so what I'd like you to do, ones are going to talk to the twos about the excluded value. How do we figure out the excluded values is step 1, okay, on both of these. And then twos, pick a problem and talk about how we solve or simplify the rest of the problem and write the final answer, okay? Ready, set, go. Okay, so number 3, excluded value. Talk about the excluded value. How do you get there? And you're doing step 1 only on your whiteboard. Step 1 only on your whiteboards. Excluded value. Step 1, you take 25n cubed, make it equal to 0. We're trying to figure out excluded values. We want to n by itself. We divide both sides by 25. 0 divided by 25 is still 0. N cubed, okay. And then when we have n cubed, we ask ourselves what times itself 3 times is going to be 0, and it's going to be 0. The mathematical step here is take the cube root of both sides. We haven't talked about that yet, but the concept is we have talked about. Okay, so n cannot equal to 0, right? Because it's undefined, all right? All right, continuing on, I want you to finish off the problem. I want you to go through step 4 on your whiteboards. Go. If you didn't get it, here we go. You need to simplify your original problem. So remember, it's like saying 20 times n over 25 times n cubed. We know that 5 goes into both 20 and 25, 4 and 5. We have n to the first in the numerator, cross out n to the first. And then we have n squared in the denominator, so we have 4 over 5. N squared, it's a simplified form, semicolon, include our excluded values, which is n is not equal to 0. We don't want that, okay? Number 4. We're at number 4 now, okay? Okay, number 4. Turn to your neighbor and tell him, how would you factor step 2? So I want you to do up to step 2 for me on your whiteboards, okay? Ready, go. By the way, what was our excluded value for step 1? 0. Okay, good. So we have AK, in case you didn't get it, AK squared is equal to 0. Divide both sides by 8. This is step 1, by the way. K squared equals 0. Square root of both sides. K cannot equal to 0. Okay? So Jonathan said that we could factor out a 2 and a K. Okay? So when you factor out the numerator, you should have a 2K minus 3. Denominator is 8K squared. Or it could be 8 times K times K. Okay? Finish off the problem, please, on your whiteboards. On this example, continuing on, you can 2K can be simplified with AK. We know that, we know that in both 2 and 8, we know 2 goes into both of them, so 2 goes into 2 ones. 2 goes into 8 4 times. We can cancel out a K here and a K here. So we're left with, in the numerator, we have 1 times 2K minus 3, which is 2K minus 3. Denominator, we have 4K. Okay? And then we have our excluded value of K cannot equal to 0. Okay? Continuing on here. Number 5, okay? This is just like number 4. I want you to go all the way through now. All the way through. Number 6, here we go, last one. Okay? So we have a couple of problems you could apply Xbox to, so the numerator and denominator, okay? Once you get to step 2, I'd like you to discuss with your neighbor what your factors are going to be for your Xbox. Here we go. On number 6, your first thing you do, take your denominator. You go m squared plus 3m minus 4 is equal to 0. We could factor your denominator. We know it's going to be m plus 4 times m minus 1 is equal to 0. Zero product property, m plus 4 equals 0. M minus 1 equals 0. So it's going to be m cannot equal to negative 4, and m can't equal to positive 1. Okay? Then you take the numerator, you factor it. We got the numerator is a perfect square trinomial. It's going to be m minus 1 times m minus 1 over. The denominator we refactored right here, m plus 4 times m minus 1. You don't have to do it again, so you just copy this section. And then you're going to notice you have m minus 1. You can cancel out here and here. These binomials we can't cancel out, so we have m minus 1 over m plus 4. Okay, and we know that m is not, we can't have it equal to negative 4 or 1. Okay? So, continuing on, that's the end of the lesson. I want you to answer 3 questions, okay? And I'm going to add one more question. Question 1, ones are going to tell the 2s. What did we learn? Question 2 is how do we do that, okay? Or how do we do it? This is question 2. This is for 2s. And then I want you to look back at an example. Together, what does it mean in the big picture of things, and use a specific example, okay? So, I want you to talk, okay? Ones are telling 2s. What do we learn? 2s. How do we do it? 3, or ones again, what does it mean? And then together pick a specific example. Ready, set, go.